video, we are going to learn about logic gates and truth tables. Let us start with logic gates. What is a logic gate? A logic gate is a circuit which is used for basic logic expressions. These basic logic expressions are also called as Boolean expressions. It is the most basic building block of combinational logic. What is a combinational logic? As explained just now, it is a set of logic gates which will help us build the logic. Set of basic logic gates which will help us build the logic. There are basically three logic gates. Not, or, and there is also one more logic gate which is exclusive or. So these are the basic logic gates which will help us in all of our Boolean expressions. Now let us understand what is a positive logic. A positive logic is where the high is denoted by 1 and low is denoted by 0. For example, 5 volts is denoted by 1 and 0 volts is denoted by 0. Now, what is a negative logic? A negative logic is where low is denoted by 1 and high is denoted by 0. For example, minus 5 volts is denoted by 1 and 0 volts is denoted by 0. So this is how positive and negative logics will be there. Most commonly used logic is positive logic only unless it is mentioned. So now let us try to understand what a truth table is. A truth table lists all possible combinations of input binary variables and its corresponding output of logic system. The output of the logic system can be found from the logic expression. For example, if input variables are 1, then it can be either 0 or 1. The possible combinations can be either 0 or 1 if your input is only 1. But if the input is 2, then the possible combinations in binary will be 2 power 2, where 2 is the radix for binary and 2 is the input combinations here. Okay, the total possible combinations will be 2 power 2, which will be 4, and they can be 0 0, 0 1, 1 0, 1 1. So this is how we will get the possible combinations. So generally, if we want to summarize this part, we can consider like if logical circuit has n binary inputs, then the truth table will have 2 power n possible combinations. Okay, so now as we have understood what a logic and truth table are, let us now look into the basic logic gates. Let us start with NOT gate. A NOT gate is a single input, single output logic circuit. Single input, single output logic circuit where the output will be complement of input. That means if the input is high, then output is low. If the input is low, then the output is high. Okay, so this is also known as inverting circuit because it inverts the value, or also known as complementing circuit because it complements its input. Suppose if x is the variable, then its output will be y equal to x bar. X is input, y is output. So its expression can be written as y equal to x bar. You can also call it as not x. Y equals not x. That is how it should be read. Okay. So now a NOT gate is represented as, the logic gate representation will look like this, where this is input, x is input and y is output. Okay, the truth table for this can be written as x, y, y equal to x bar, or it can also be written as like this. It looks like this. Okay, so now if we write the truth table for this, there are only possible inputs for x are 2, either 0 or 1. So as per the realization of NOT gate, since y is complement of x, so the output y will be, if the input is 0, output will be 1, and if the input is 1, output will be 0. So this is the truth table for NOT gate. Okay, now as we understood how NOT gate works, let us now try to get for OR gate. So here an OR gate is a 2 input 1 output logic gate for which the output is low if both inputs are low. That is, if A and B are inputs, then Y will be the output, which can be represented as A or B. The plus means or. It should also be pronounced as or, not as plus in this. Okay. So now if there are two inputs, there are only four possible combinations, which are 0, 0, 0, 1, 1, 0, 1, 1. Correct? So as the definition defines here, the output is low only if both inputs are low. So only this is the scenario where we are seeing it. So the output is 0 here. In remaining everywhere it is high. Okay, so this is how OR gate truth table can be realized. The representation of OR gate can be given as 1, 2 inputs, and it will look like this, and this will be the output Y. So here is our A and B inputs, and this will be our Y, where Y is equal to A or B. Okay, so this is how an OR gate can be realized. If there are more than two inputs, then for that also truth table can be realized. But the same definition follows over there too, which is the output is low only if all the inputs are low. Okay, so this is how OR gate can be realized. Let us try to understand how AND gate works. Let us see how AND gate works now. So, AND gate. An AND gate is a logic circuit for which there are two or more inputs and one output, for which the output is high only if all inputs are high. Okay, so how can we clearly tell this? So suppose if we have inputs A, B, and consider the output as Y, where Y is expressed as A and B. Here dot means and. Okay, so we know all the four possible inputs for this: 0, 1, sorry, 0 0 0 1 1 0 1 1. So as the definition tells here, output is high only if all the inputs are high. So all the inputs are high only in this scenario, so our output will be high only here. Remaining all conditions are 0. So this is how a truth table for AND gate can be written. So let us see how AND gate is represented. An AND gate can be represented like this. Here are our inputs A and B, and here is our output Y, where Y equal to A and B. So as the name or pronunciation itself says, only if A and B are high, then only the outputs will be high. So this is how an AND gate can be realized. Now, let us try to understand the final basic gate, which is exclusive OR. As the name itself says, it is exclusive OR. If we consider OR truth table A, B, Y, where Y equal to A plus B, correct? So, for this 0, 0, 0, 1, 1, 0, 1, 1 are the inputs. As the name itself says here, it is exclusively OR. That means if both are same, then it is low. If both are different, then only it is high. Okay, so here we have different only in these two scenarios. So only in this region it will be high. Remaining everywhere it will be low. So the XOR gate can be realized as like this. Okay, so Y equal to A XOR B. So this is how it will look. And the representation of this will look like this: A, B, Y, where Y is equal to A XOR B. So this is how all the basic logic gates are realized using truth tables. Thank you.